Hello. This is a representation of our sun, albeit a somewhat poor one. The sun emits a lot of energy. But how much energy does it emit? And at what rate does it emit it? The only equation you'll need is the following one. Q, or the amount of heat radiated, is equivalent to the emissivity of the object, which is somewhere between 0 and 1, times the Stefan-Boltzmann constant, which is written down below here. It's 5.67 times 10 to the power of minus 8 joules divided by seconds, times divided by meter squared divided by Kelvin to the 4th power. So let's get back to the equation about the heat. You multiply it by the surface area of the object times the amount of time that has gone by, and then you multiply it by the temperature in Kelvin to the 4th power. Alrighty guys, we are going to now figure out the surface area, the amount of energy that the sun emits every second. This won't actually be as hard as you might think, because the time is just 1 second, so we basically don't even need time for this variable at all. The emissivity of the sun is, we're just going to assume it's 1. And I think it is 1, or very, very close to 1. So all we need is the Stefan-Boltzmann constant times the area, surface area of the sun, times the temperature to the 4th power. We know, so the area, you can look this up for yourself and figure out, but the surface area of the sun is 6.09, it's 333, etc., times 10 to the power of 18. So we're just going to multiply this by times 5.67, and then divided by 10 to the power of 8. Now, that will actually be, let's see, will be 10 squared, and again squared. So, this will be that. We'll get that from that. So, it's a lot smaller, but then we're going to multiply by the temperature. The temperature of the sun is 5,800 degrees Kelvin. Now square that. Now square that again. So what do we get? This. Roughly 3.90, just basically 3.9 times 10 to the power of 26 joules per second. Or 3.9 times 10 to the power of 26 watts. That is a huge, a huge amount of energy. So it's a lot more energy than that we use and consume every single year. The sun, in 1 second, will probably produce more energy, way more energy, than humans will throughout the span of our existence. Something to think about. Just to think about how much energy is in our sun. I would like to thank you, the viewer, for watching. And I'd like for you to like, subscribe, and comment on the video, and share. And until next time, peace out.